Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today, problem is another installation about this body that sits on the surface, and we apply some external force to this, but it's not important which numbers are here. But what they want us to build the graph, how F friction, how it is depends from external force F. It's a function of external force F. Because when we apply small force, friction reacts in such a way that it prevents of moving. We apply a little bit more F and the friction grows. And then at a certain moment, this static pattern is broken, and this moment is when a friction reaches this value, and at that moment it becomes kinetic friction and we start to move with acceleration. So basically there are two cases: static, and static means we already wrote, I can write this vector sum, but we went through this so many times that in static F friction equal F, everything is balanced, acceleration is equal 0. What would be the graph of F friction, this function, how it depends on this variable F? Of course it would be a straight line. F friction, F 45 degrees, no matter what F you have exactly the same F friction. No matter what you have exactly the same friction. Keep growing this F, and suddenly this static case becomes kinetic case. And this kinetic case becomes when F friction reaches maximum that it can reach. And this maximum is mu n. And in this case it is maximum mu mg. And so the moment F reaches some value, F friction reaches maximum, and it does not change. So this would be the graph. Two lines with a kink. And this would be mu mg, and this would be mu mg, and this is when they just suddenly, instead of static, we have kinetic. Instead of acceleration equal a acceleration equals 0, we have here a is greater than 0. So this is kinetic case, and this is static. And that's about it. But the only thing that I want to tell that in reality, there is a little bit bump here on this graph. If you will start measuring it with a real spring scale and pushing forces, you will see from experiments that you always have to overcome a little. How little nobody knows. It's 1%, 2%, 0.5%. It depends on the surface, depends on this friction coefficient mu. But in reality, if you would put a very precise experiment, there would be this bump. You have to apply a little bit more force than mu and a little bit. This F has to be a little bit more than this maximum force, and then it starts to go, and then everything is stable, and friction equals mu n. But most likely they're not interested in this effect, and we can draw this like a kink with a kink. I hope you liked it. I hope you want more problems like this. So subscribe, like, ask a question. Thank you.